Okay, students, now we'll solve some examples. You will find this example in the second midterm review. Okay, look at this level. What if we have this level curved with a circular track and then ends starts from A to B to C, the D at the top of this circular track, and the end point, which is E, at the same height as A. The mass of this car is 200 kilograms. Its initial velocity at A is 0 meters per second. The height of the point A is 10 meters. The height of point B is 4 meters. The height of point C is 0 meter. It is the reference. The height of point D is 8 meters. The height of point E is the same as A, which is 10 meters. Okay. What is the required from this example or question? We need to find the potential energy and the kinetic energy at each point. We don't have any given, just we have the mass, the heights, and the initial velocity at A. And then we need to find the speed, not the velocity, the speed. It is just a numerical value, a scalar value. At each point, we need the speed at A, at B, at C, at D, and at E. And we need to rank the potential energy, the kinetic energy, and the mechanical energy for each point. Okay? Let us now see the formulas for the potential energy and the kinetic energy. The potential energy, or the gravitational potential energy, is equal to mgh. M is the mass, g is the acceleration due to gravity, and h is the height. The kinetic energy is equal to half multiplied by m multiplied by speed squared. Okay, we can find it at each point. Let us start with the potential energy. The potential energy at A is equal to the mass, which is 200, it is constant, g 9.8, which is constant. H will depend on the point. The height at A is 10 meters. Okay, this is A, the height is 10 meters. So the potential energy will be 19,600 joules. The potential at B, the mass, multiplied by G, multiplied by the height, which is 4 meters for B. The potential energy at C, the height at C is 0. Then the potential energy is 0 at C. Okay, now the potential energy at D, at this point, and the highest point of the circular track. You will see that in the lab. The potential energy will be just the mass, and the acceleration is the same, but you need just to change the altitude or the height. It is 8 meters. The potential energy is 15,680 joules at this point. And the potential energy at the point E, which is the same height as A, 10, it is 19,600 joules. It's the same as A. Now let us start to find the kinetic energy. The kinetic energy at the point A is equal to half multiplied by the mass multiplied by the velocity at that point, VA. VA is 0. Okay, then the kinetic energy is equal to 0 at first point, at the initial point, which is A. And that is logical because the velocity is 0. The kinetic energy at point B is equal to half multiplied by the mass, which is 200, the same, multiplied by the speed squared at point B. The kinetic energy, we don't know this speed yet. And the kinetic energy for each point is equal to half multiplied by the mass by the and multiplied by the speed at each point squared. We don't know these values, okay? We can't find the kinetic energy in this way. How can we do that? Let us see here. The total mechanical energy for this system, which is conserved system, or the potential energy is conserved for the gravitational force, is equal to the potential energy plus the kinetic energy, which is always constant for this system. So the mechanical energy at the point A is equal to the potential energy at the point A plus the kinetic energy at point A. The potential energy, we find it now, it was 19,600 joules. This is the potential energy at point A. The kinetic energy at point A is 0. Then the total mechanical energy is 19,600 joules, which is constant. At A is equal at B, and at C, at D and E. It is constant. The total mechanical energy E at A is equal to E in general at any point, which is equal to 19,600 joules. Okay, I will use this bit of information to find the kinetic energy from the formula of mechanical energy. Mechanical energy is equal to the potential plus the kinetic. Then the kinetic energy, just if I move the potential to this side, it will be a negative sign. So the kinetic energy is equal to the mechanical energy minus the potential energy. Okay, at each point. At point A, we know the kinetic energy is 0. We compute it here because the velocity is 0. Now let us compute it by using this way. The mechanical energy is equal to 19,600. The potential energy at point A is equal to the same number, and the result kinetic energy at point A is 0, as we solved. Okay, the kinetic energy at point B is equal to the total mechanical energy, which is 19,600, which is constant in all of our solution, minus the potential energy at B. The potential energy at B, we solved it, 7,940. The kinetic energy at B is equal to 11,760 joules. Okay, now we have kinetic energy. We can find also the velocity at that point. Okay, the kinetic energy at point C is equal to the total mechanical energy, which is the same number, minus the potential energy at point C. The potential energy at point C now, the point C is at the 0 level. The potential energy is 0. Then the kinetic energy is equal to 19,600 joules. It is all of the mechanical energy is converted to kinetic energy at this point. All the mechanical energy at point A was potential energy, just potential energy. Here it was potential energy plus kinetic energy, but the kinetic energy is 0. So all the mechanical energy at point A was U. Here U plus K at point C, but U is 0. So all the mechanical energy now converted to kinetic energy. Kinetic energy is equal to the total mechanical energy. At point D, the same thing. The total mechanical energy minus the potential at point D. The point D is the highest point in the circular track. The potential energy at that point is 15,680, and the kinetic energy will be 3,920 joules. It reduced at that point because the height at that point is 10 meters, 8 meters, I'm sorry. It is near 10, and most of this, the mechanical energy converted to potential energy and kinetic energy, but the kinetic energy is less than the potential energy because the potential energy is 15,000. The kinetic energy is 3,920. Okay, at point E, this one, which is the same as A, I think all the mechanical energy will return to potential energy. Look, the potential energy is equal at point E, the same as the mechanical energy. The kinetic energy at this point is 0. The kinetic energy at this point is 0. It's the same as at the point A. This is 0. The car velocity here is 0, and also the car velocity here is 0. It returns to stationary situation. Okay, now we can find also the velocities or the speeds from the kinetic energy formula, which is equal to half mv squared. V squared is equal to 2 multiplied by k divided by m. You can find that, and the speed is equal to the root of that value. We need to take not the positive and negative, just the positive, because we are looking about the speed. At point A, the speed at point A is equal to the root of 2 multiplied by the kinetic energy at point A divided by m. The kinetic energy at point A is 0. We find that. So the root of 0 is 0. The velocity at A is 0. We know that. The velocity at A is 0. Okay. The velocity at B, at the same, we need to put 2 over m is constant at each point. But we need just to change the kinetic energy. Kinetic energy at B, kinetic energy at C, kinetic energy at D also. Now, from that, we can find the speed at B, the speed at C, the speed at D. The speed at B is 10.88. The speed at C is 14. The speed at D is 6.3. The speed at E, which is the final point, this one, it's the same as A. It will be 0. Okay. Let us now look at these values of the speed. At point A, the speed is 0. And, here the speed is 0. Also here, the speed is 0. But the speed at B, here, V, is equal to 10.8. At C, it is 14, the maximum value of the speed. At point D, 6.3. It is even less than point A, because most of the energy is potential here. As we said, it is 15,680. Okay, so the velocities, the maximum velocity at point C, then at point B, then at point D. Now we find the velocities. You see, it is simple when we divide that problem to small pieces, and it is more simple than using V2 is equal to V1 plus AT and these equations of motions. Because here in this one, in these equations, we have X component and Y component. Here, we don't need to use X component, we don't need to use Y component. We just solve the speed, okay? Now, the third one, we need to rank the potential and the kinetic and the mechanical energy. We don't need to rank, there is no need to rank the mechanical energy, because all of the mechanical energies are equal. Because we are dealing with a gravitational force, which is conservative force, okay? Now let us rank the potential energy. As we see the height for the point A and point E is the same. Then the next point is D. The next is B, and the last one at 0 level is C. So, because of heights, we can know the potentials. At heights A and E, the potential is equal, which is 19,600. At point D, which is the next point, the potential is 15,000 something. The point B is 7,800 and so on. And at the point C, which is the lowest point, the potential is 0. So we can rank it downward or upward. So in this case, U potential at A is equal to potential at E, which is larger than the potential at D, which is larger than potential at B, which is larger than potential at C, which is equal to 0. If we have this point, another point, which is F, then the potential is for C and F is the same. If we have another point here, which is G, then the potential of D and G are the same. And if we have also the same point here, these are the same height points, have the same potential energy and the same velocities. You will see that. For the kinetic energy, the kinetic energy at point A and E, initial and the final points, the kinetic energy was 0 because the velocity is 0. The kinetic energy at point D, here, is 3,920. Then the kinetic energy at point B is 11,000 and something. And at point C, the maximum kinetic energy, which is the total E, which is 19,600 joules. So we can find that the kinetic energy is maximum from down to up. The lowest point has the maximum kinetic energy. Then if we go up, then the kinetic energy will be less and less to reach point 0. At the highest point A and E, we don't have negative kinetic energy. This is forbidden because the kinetic energy, look at this important point, half is positive. The mass is always positive. V square is always positive because it is square. So always kinetic energy is positive value. Okay. Now we can rank the kinetic energy. It is equal to 0 at point A and E, and it is less than the kinetic energy at point D, which is the lowest than the highest point. And the kinetic energy at point B, then, which is lower than point D and higher than C, which has the largest kinetic energy. Please resolve this example. You will find it in the papers uploaded, and it is very important in physics. Thank you.